Welcome to Hyperscale Data Center Mega SOP Part 1. On-time delivery, OSHA compliance, life safety, workforce sustainability, and fiber copper quality. Project: Hyperscale Data Center Operations. Applies to TPMs, LVVs, GCs, subcontractors, consultants, QA and QC teams, facility management, client representatives, and validation teams, and network deployment teams. By José-Alonso Hurtado González. Objective: complete projects safely and on schedule by prioritizing OSHA compliance, protecting human life, ensuring quality, and maintaining reliable fiber and copper infrastructure. 1. Purpose. The purpose: establish standardized procedures for the safe, efficient, and timely execution of hyperscale data center operations, including energization, cooling readiness, fiber and copper installation, validation, failure mitigation, root cause analysis, and recovery. Built on real-world validation experience, it strengthens safety, QA and QC, workforce sustainability, and on-time delivery, while reducing failures and rework. 2 core principles. 2.1 Protection of human life above all. Human safety is the foremost priority of this initiative. No timeline, energization, validation, or productivity target outweighs the health and well-being of personnel, guests, vendors, or management. Work shall not commence if it introduces unwarranted dangers to workforce members. Mandatory life safety standards. Unsafe work is prohibited. No energization, validation, or construction shall proceed without required safety measures, properly trained personnel, and leadership accountability for workforce safety. 2.2 Integration of safety, quality, and schedule. Project success. Meeting project schedules requires safe work practices, trained personnel, proper sequencing, real-time collaboration, quality installation, sustainable work hours, and timely reporting of issues. 2.3 Zero Tolerance Principles. Zero Tolerance Principles. No PPE, lockout tagout, OSHA qualification, clean environment, hydration, approved work sequence, or QA and QC approval means no work, no energization, and no validation. 3. Minimum training, certification, and job site entry requirements. 3.1 OSHA requirements. OSHA requirements. All personnel must have OSHA 10. Supervisors and safety-sensitive personnel must have OSHA 30, and no one may work on site without the required OSHA certification. 3.2 Technical qualification requirements. Technical qualifications. Personnel performing fiber, copper, testing, or validation work must be trained for hyperscale environments with preferred BICSI, fiber splicing, manufacturer certifications, and knowledge of TIA ISO standards. 3.3 Training deficiency. Risk. Training standards. Unqualified personnel shall not perform critical fiber or copper work due to the risk of contamination, installation errors, infrastructure damage, and validation failures. 4. Roles and accountability. 4.1 TPM Technical Project Managers. TPM. Responsibilities. Coordinate subcontractors, schedules, and milestones while removing obstacles and preventing unsafe or fatigue-driven decisions that compromise quality. 4.2 General Contractor and all partners. GC and all partners' responsibilities. The GC, subcontractors, contractors, and consultants, are responsible for safe execution, field coordination, quality installation, and continuous schedule communication. For QA and QC teams. QA and QC responsibilities. QA and QC teams verify installations, conduct audits, review validation readiness, track failure trends, and enforce compliance with quality standards. 4.4 Managers, foremen, and leads. Field leaders must give precedence to crew safety, access to hydration, managing fatigue, accurate task sequencing, maintaining cleanliness, safeguarding live systems, monitoring the quality of team output, and preventing overscheduling and burnout. 4.5 Client and facility management. Client and facility management maintain authority over project approvals, site integrity, operational controls, and primary readiness milestones. 5. Cross-team communication and coordination. 5.1 Mandatory stakeholder alignment. Coordinated communication must be maintained among TPM leadership, the GC, electrical contractors, MEP contractors, coolant system contractors, LVVs, validation vendors, QA and QC consultants, facility management, client representatives, and network deployment teams. 4.2 Required communication channels. All matters affecting safety, scheduling, quality, hydration, fatigue, validation, energization, or infrastructure readiness must be promptly reported through war room communications, Slack channels, direct TPM escalation, and daily handoff documentation. 5.3 Daily coordination expectations. Necessary stakeholders must provide regular updates on completed tasks, percent completion, current risks and barriers, safety concerns, workforce availability, fatigue exposure, hydration and heat stress issues, pending inspections, and validation dependencies. Line 4 Escalation conditions. Immediate escalation is required for safety violations, missed updates, unreported delays, unauthorized work, improper sequencing, excessive work hours, lack of rest days, recurring validation failures, unresolved quality defects, infrastructure changes after validation, and poor communication that jeopardizes schedule or quality. 6. Daily execution framework. 6.1 Pre-shift planning. Before each shift, leadership shall review handoff reports, blockers, failed racks, energization and cooling status, validation updates, workforce levels, tool availability, OSHA compliance, QA and QC results, hydration stations, fatigue exposure, and rest day compliance. Then issue a daily execution plan, identifying target rows, pods, and racks, priority tasks, safety concerns, staffing, fatigue risks, hydration and break compliance, inspection points, and recovery action. 6.2 Start of shift alignment. At the commencement of each shift, involved leads will align on safety briefings, scope of work, deadline priorities, subcontractor coordination, energization sequencing, cooling readiness, fiber readiness, validation sequencing, heat stress precautions, fatigue evaluations, and crew balance and supervision. 6.3 Controlled field execution. The worksite shall remain controlled at all times through designated access points, clear aisles, proper housekeeping, required PPE, safe hydration and break access, controlled interaction with live fiber and copper systems, and protection of validated infrastructure. 7. Required task sequencing. No team may overlook the prescribed sequence. Standard critical path. 1. Verify safety measures to protect human life, personnel well-being, building integrity, and all equipment. 2. Confirm that all subcontractors, consultants, the client's representatives, LVVs, TPMs, and other stakeholders maintain continuous communication and coordination to prevent delays, resolve issues promptly, and achieve project milestones. 3. Complete and verify the routing, placement, dropping, labeling, and readiness of fiber, bulk, fit-out, and patching, copper infrastructure, and racks. 4. Inspect and re-inspect connector cleanliness and verify patching complies with the latest engineering patch cut sheet. 5. Confirm the chillers are operational and maintaining the required temperatures for proper equipment cooling. Verify the MEP contractor has fully commissioned the system and the client's facility maintenance team has approved it for operation. 6. Connect and test cooling systems, ensuring pressure testing is 100% complete to prevent leaks during and after validation. 7. Inspect and re-inspect connector cleanliness and verify patching complies with the latest engineering patch cut sheet. 8. Completion of pre-commissioning authorizations. 9. Approval for rack energization. 10. Approval for validation readiness. 11. Execution of validations. 12. Initiation of recovery processes if warranted. 13. Performance of revalidations. 14. Turnover documentation for each data haul must be complete, accurate, and submitted for final acceptance. Failure to follow the correct sequence contributes to avoidable failures, diminishing confidence in schedules, and increasing rework. 8. OSHA-aligned safety requirements. 8.1 PPE. The minimum required personal protective equipment, PPE, includes a hard hat, safety glasses, a high-visibility vest, suitable gloves, and EH-rated footwear. 8.2 Electrical safety. Enforce lockout, tagout, LOTO procedures, permit only authorized personnel to perform electrical work, require pre-commissioning authorization before energization, and prohibit work on unverified or unsafe energized systems. 8.3 Housekeeping and cleanliness. Maintain clean work areas by performing HEPA vacuuming as required. Prohibit dust, debris, and contaminants in critical areas, as cleanliness is essential for connector handling, optics, and overall quality control. Before entering the data hall, all personnel must wear booties, maintain clean PPE, work attire, tools, and equipment. Failure to comply may result in removal from the job site. 8.4. Hydration and heat stress prevention. Provide unrestricted access to potable water and encourage frequent hydration, as it is essential to worker safety. Personnel exhibiting signs of dehydration or heat stress must be removed immediately for evaluation, and hydration access shall never be restricted for production purposes. 8.5 Fatigue prevention and work-life balance. Prevent fatigue-related safety and quality risks by limiting construction personnel to a maximum of 60 hours per week, providing adequate recovery time and 2 weekly rest days, and removing workers impaired by fatigue until they are fit for duty. 9. Approved workforce scheduling model. 9.1 Maximum work hour limits. Hydration is a life safety necessity. Limit construction personnel to a maximum of 60 hours per week. Provide 2 mandatory rest days. Prohibit 12-hour shifts for 7 consecutive days or any scheduling that compromises recovery, and never override life safety requirements for production. 9.3 Recommended 3-shift model. A 3-shift 10-hour framework is recommended to improve safety, quality, continuity, and sustainability. Shift 1, 5 a.m. to 3 p.m. Shift 2, 1 p.m. to 11 p.m. Shift 3, 9 p.m. to 7 a.m. Shift overlap facilitates safe transitions, coordination updates, safety briefings, balanced manpower, and reduced fatigue exposure. 9.4 Leadership responsibilities. Managers, foremen, supervisors, and leads shall prioritize hydration, fatigue prevention, mandatory rest days, appropriate staffing, and the reassignment or removal of fatigued personnel to protect worker health, safety, morale, and productivity. We've reached the end of Part 1 of the Hyperscale Data Center Mega SOP. Continue to Part 2 in the next video, where we'll cover the next phase of the standard operating procedures and continue building the complete operational framework. Thank you for watching, and we'll see you in Part 2. For additional information, contact José-Alonso, Hurtado González.